Okay, can everybody hear me okay? Yes? Good stuff. First of all, I'd like to start just briefly by thanking all of you for coming. Your time is appreciated. Secondly, this is only the second time that I've ever spoken in a VMUG, so if it seems like I'm a little bit nervous, it's because I am. So anyway, let's get on to some good stuff. But there's a couple of sales and marketing type slides in here, so I won't spend too much time on them. I'll get on to the good stuff that we're all really here for. But first of all, a little bit about us, Condusiv Technologies. Some of you may have known us in the past as Diskkeeper. Has anyone used Diskkeeper in the past? Have a quick show of hands? A few? That's good stuff. So, for those guys who put their hands up, I want you to do something for me right now. I want you to take those Diskkeeper glasses off and put a fresh set on, because what I'm going to talk about today is a whole new architectural approach to improving the performance of your virtual estate. But as I say, first, a little bit about us. We've been around for over 32 years, a long time in the software game. We've sold over 40 million licenses worldwide, which is a good amount. Our software can be found in 90% of the Fortune 500 companies. We've licensed a lot of our technology to OEM partners as well, people like Lenovo, Acer, Asus, Fujitsu, HP, and there's probably a few others that I've forgotten to mention. But, oh goodness. It's always great when your wife phones in the middle of one of these. Sorry about that. So, yeah, they use our technology to make their laptops and ultrabooks stay running fast. They use our caching techniques with little SSDs to improve the performance of those. In fact, I think now 9 out of the top 10 notebook manufacturers use our software. The only one I think that doesn't is Toshiba, and we're currently in talks with them as well. We are a gold competency partner with Microsoft. We have been since about 93, whenever they brought out Windows NT 4. And we're a technology alliance partner with VMware. So this software has been real-world tested on a wide variety of different systems all over the world with many different applications. It's very robust, very proven technology. So let's talk a little bit about the problem that we're pretty much all facing, and I think this echoes what Joe Bagley was saying in the keynote speech earlier today. There is an explosion in the amount of data that we're having to deal with. Analysts like IDC and Gartner are telling us that over the next 10 years, the number of files that we're having to deal with are going to grow by 75 times. That's going to cause a massive I/O explosion down to the storage. And the problem is that the storage hardware can't keep up with that growth, with that pace, cost effectively. So whilst the number of files we're going to have to deal with is going to grow by 75 times, roughly, the performance of storage hardware, we're told, is only going to grow by about 8 times. So this idea or this solution of throwing more storage hardware at the problem to spread the load of the I/O traffic is going to become a very expensive dependency. Now this is a great slide. This is what I call the I/O blender effect. You have all of the random, very highly randomized I/O traffic coming from disassociated virtual machines. You might have, over here, you might have SQL Server, Exchange, Oracle, File and Print, a VDI environment. They're all generating this I/O traffic and funneling it down towards the storage where it can become bottlenecked, especially if you put a lot of VMs over the same storage. As a result, people tend to throw more spindles into the sand. They may buy another sand just to try and spread the load of this I/O traffic to maintain performance. As I said before, it becomes a very expensive dependency. So this is the new architectural approach that I mentioned before. It's a software-only approach, so you don't need to keep buying this additional hardware unless you need the actual capacity that that hardware is going to give you. It's virtual machine acceleration software for Windows. It improves application performance, it says here, by 50%. That is a rough average. Often it's more than 50%. It's quite a conservative average. Sometimes there's a little bit less, if I'm honest. It depends on the workload and how I/O intensive that particular application or server is. One of the key things is that it optimizes reads and writes at the source. inside that guest Windows operating system. And that's very important, and I'll expand on that a little bit later on. But the bottom line is that it reduces the amount of I/O traffic that your storage has to deal with. And that's got to be a good thing, right? So, here are the two main performance barriers. Unnecessary write I/Os is the first one. This is caused by the way that Windows writes a file and tends to split it up into pieces, and each piece has to travel down the storage stack to your storage in a separate I/O packet. So if Windows is going to write a file and split it into 100 pieces at the NTFS layer, the first chunk of data gets written and that travels down as an I/O. Then the next piece gets written, that travels down as a separate I/O, and so on and so on and so on, 100 times until that file has been written. That's very inefficient. It's an inefficient use of resources, and it's very inefficient for your SAN to stripe in small pieces across its spindles. The second problem is unnecessary read I/Os. This is where typically every read has to travel the full distance between that virtual machine through the hypervisor, through the physical host, through the storage area network, through to the storage, and all the way back again, whenever you want to read something. Again, that steals bandwidth. It's very wasteful. So this is how Velocity overcomes these barriers. The first one is write I/O optimization. Now, it's important to point out that we're not bypassing Windows in any way. It's still Windows that's safely performing the write. It's sending down a standard NTFS I/O packet towards the storage. What we're doing with this is providing an extra layer of intelligence to that Windows write driver so that it finds a large enough area of free space to write that file without having to split it up. The result is that you get larger, more sequential I/O packets hitting the SAN, which is a lot more efficient for it to stripe across its spindles and then subsequently read back in. So that's going to lower things like I/O queue depths and help to decrease latency. Then we have the read I/O optimization, and this is pretty cool stuff. This takes a portion of memory inside the guest Windows operating system that isn't being used by anything else, and it sets up a RAM cache. Now think for a moment, if you can cache the most commonly read data blocks from your storage right at that very high level in the storage stack inside the Windows operating system, number one, it's as close as we can get to caching next to those applications that are generating the I/Os in the first place. Secondly, DRAM is a lot faster to use as a cache than 14K SAS drives, SSDs, even PCIe flash cards that you can put in the physical host. DRAM is faster. And if you can satisfy a good percentage of the reads from there, you've offloaded them away from the storage, which frees up bandwidth for the rest of the I/O traffic that does still have to flow out to the storage. So, IntelliWrite, I skipped a slide, I apologize for that. It's basically providing that layer of intelligence to Windows so that it doesn't have to split these files up and send each piece down as a separate packet. Because we're optimizing there, it means that we are storage agnostic. We don't care if you're using storage from EMC, NetApp, HP, Dell. It doesn't matter if it's a normal SAN, a tiered SAN, spinning disk, SSD. We're completely agnostic of all of that. So if your storage is compatible with Windows running above it, it is going to be compatible with this software. IntelliMemory, this is the name we've given to the caching part of the software. And as I'm assuming we're all fairly technical here, I'll tell you a bit about the caching algorithms, because this is pretty cool stuff. There are many different types of algorithms that we use, but the three main ones are proactive caching, reactive caching, and read-ahead caching. Now, read-ahead caching is fairly self-explanatory. That's quite useful in streaming audio or video type situations. Reactive caching, as the name suggests, is very good at noticing if you're hitting a common set of clusters often, and it'll get that data put into the cache very quickly for you. But the really clever stuff is the proactive caching. This uses a system monitoring or telemetry technique to learn over time what type of applications are being run on that machine, what type of data they are accessing, and at what different times of the day. Now that's quite important, because you might be doing a particular type of load in the morning, you might be doing something slightly different with the machine in the afternoon, maybe running some reports, you might be running maintenance routines overnight, which is a completely different type of load altogether. The point is the software can automatically and dynamically adjust itself depending on your real-world workloads without you as a system manager having to tune it in any way or having to think about what things need to be pinned to the cache. There's absolutely none of that. In fact, we, a number of years ago, registered the trademark Set It and Forget It, which seems to fit pretty well to this software. So here's the blender effect again, before and after velocity. So on the left-hand side, you have this chaos of I/O traffic, which is all being funneled down towards the storage. On the right-hand side, with velocity sitting in those guest Windows operating systems, first of all, the storage is dealing with less I/O traffic because a good portion of those reads have been offloaded away from it. And the writes that do go out are in these larger, more sequential I/O packets. So the bottom line is we've lightened the load on the storage. But what does that mean? What does that mean to you as a company? First of all, if you have I/O intensive applications, it means that they can now get more work done in the same amount of time because they're having to wait less on the storage. It also means you can now put more machines over the same storage than you otherwise would be able to do and maintain the same level of performance. Now, this is quite an important slide. This really highlights where we're sitting in the storage stack. So we're right up here inside that guest Windows operating system. As I mentioned before, it means that we're hypervisor agnostic, we're storage agnostic. It also means that everything below that point in the storage stack benefits by receiving the traffic in an already optimized manner. So, for example, down in your tiered SAN here, if you have SSDs as your tier 1, now that becomes more productive because it's only dealing with truly 100% productive I/O traffic rather than wasting its time on 30% or more of these excess unnecessary I/Os. Similarly, if you have a PCIe flash card, maybe like a Fusion I/O card or something like that here, and sitting in the physical host, well, now we make those guys look good as well because we've already optimized the traffic for them. It maximizes the return on the investment you've made there. And often we find that you can achieve the performance gain that you're after without the need for this additional hardware. Now, this is a question I get asked quite a lot, especially on the stand. People say, what sort of things really benefit from having velocity present? The short answer is any Windows machine is going to generate I/O traffic and is going to benefit from having that I/O traffic optimized. However, the applications that are really I/O intensive are going to benefit the most. So things like VDI environment, Exchange, SQL, streaming media, business analytics, where you're producing a report from a number of different disk locations. Some of you may be wondering about SFDC. I asked that myself when I first saw this slide. It stands for Salesforce.com, and that's an interesting one to talk about for a moment. With Salesforce, I'm assuming most of you have, if not used Salesforce, know about it. They have paying customers who pay a subscription every quarter or every however much it is. So you take one of their servers, and let's say it's hosting 100 paying customers. Well, now with this software, you can accelerate the performance of that machine so that now you may be able to host an additional 50 paying customers, or maybe even an additional 100 paying customers without the need for extra hardware. So that extra subscription money, that's pretty much clear profit. Now, most of us here have bosses who I'm sure that will ring true with, and they'll like to hear that. But also, this software can do things like allow you to get more work done in the same amount of time without the need for this additional hardware. So, if you are planning to do a technology refresh in 2 years' time, well, now, quite simply, you can get more work done with what you already have. So you could defer that capital expenditure. You could defer that refresh for maybe 4 or 5 years because you don't need to buy it as quickly. Again, when you're talking to bosses and C-level people, they love that stuff. We gave the software to a third-party analyst over in the United States, a company called OpenBench Labs, and we asked them to test it for us independently, so we weren't sort of watching over their shoulder every 5 minutes and sticking our oar in. We left them to it, and they tested it, first of all, with Microsoft Exchange. So they simulated 1,800 Outlook users, They were running Exchange 2010, an AD and a DC. They found they were able to get 62% more transactions done in the same amount of time versus the same system without our software. They got 89% faster response times on Exchange and the DC. So they went from 16 milliseconds down to 0.5 milliseconds. Now, when you think there was no extra hardware involved, that's pretty cool, from just software. They got a 127% increase in the normalized IOs per second. They ran the similar test with SQL Server. So they ran 80 daemon processes on SQL Server 2012. They found they were able to get 50% more transactions done in the same amount of time, again versus the same system without velocity being present, which is awesome. That's pretty cool. 118% faster response times to SQL queries. Now, are there any guys here who are running SQL that would like to see that sort of performance gain? Yeah, a few of you. Good stuff. Now, this is a very useful part of the software, especially for people who are evaluating. So this is called the Benefit Analyzer. And I typically talk about the next 3 slides because I'm terrible at doing these types of things, so I'll try not to do that. It gives you a before and after comparison report, but the important thing is it's in your real-world environments, with your applications, with your real-world workloads. Okay, so you can see on any given virtual machine just how much benefit it's going to get from having this software. There's useful metrics on there like the workload. How many gigabytes of traffic could the machine process on day 1? How many more was it able to process on day 3 when we were optimizing? Things like what happened to the size of the IOs going out to the storage. We want to see them on day 3 when we're actively processing. We want to see those IOs bigger. What happened to the average IO response time? You can imagine if we can satisfy a good portion of those reads from DRAM, the average IO response time should come down fairly significantly. And again, these figures were run by OpenBench Labs, and they actually ran it with a copy of IOmeter. Some of you may be aware of that. It was a little utility originally created by Intel to stress test storage and network devices. So it's designed to throw as many IOs as it possibly can at the storage. So they did that, and they compared the metrics from IOmeter to the metrics in the BA report, and they found them to be the same. So these figures aren't smoke and mirrors. They do accurately reflect the performance gain that you're seeing on any given VM. So this is the bit I've normally skipped over. As I say, it runs over 3 days. On day 1, velocity won't do anything other than just look at the system and monitor it and see how things are working. On day 2, the software will tune itself based on the intelligence gathered on day 1. Think back to that proactive caching technique. On day 3, all the bells and whistles are turned on, so you have the caching, you have the right aggregation, and all of the other technologies are turned on. And at the end of day 3, you get that before and after report, that benefit analysis report, which can be printed off, saved as a PDF, included in a business case if you need to prove the software's worth to bosses. One thing that I do want to be clear about the software is that in order for it to do what it does, we do need to reboot the guest operating system. But you don't have to do that immediately. So, for example, you could install it today and reboot the system during a maintenance window at the weekend or overnight or when your next operating system updates go in. That's absolutely fine. As soon as that machine's rebooted and back online, within minutes it will start optimizing the traffic and providing you those performance gains. So, yep, I've done it again. I skipped through. So this describes the 3 phases of the BA. So day 1, it's just monitoring. Day 2, it's tuning itself. Day 3, it's actually giving you these performance gains. And you're more than welcome, and in fact, we actively encourage you to work with us when you're doing this as a proof of concept. I'm actually the technical director for the EMEA region. I'm happy to work with any of you guys. I can provide you with the software, make sure that your environments are set up in such a way that you're going to get the most value from the software the first time you run this test, because that's in our interest as well. We want to see you use the software to get these massive performance gains. Now, this is something that you don't see software companies say very often. We are guaranteeing that you are going to see at least a 25% performance gain, or the software is free. Now, of course, we're not in the business of giving away free software, but this gives you some idea of how confident we are that this stuff works. We've been working on caching technologies for 30 years. We originally started out providing caching technologies to VAX VMS systems. I'm sure most of you are far too young to remember those, but it was a long time ago. So yeah, this technology is used OEM'd to our partners. They have literally spent millions and millions and millions of dollars with us licensing this technology. They wouldn't do that if it didn't work. So we know this is tested across a wide variety of systems, way more than we could ever hope to do in a beta test or a field test. It's very robust, it works, and we're happy to guarantee it. So I'm nearly at the end. I'm sorry, I don't mean to kill you by PowerPoint. This is a brief slide showing the suite of software. At the lower end, on the left-hand side, we still have the DiskKeeper product. It's still a very good product, very much alive. It's designed really to keep physical laptops and workstations running like new by preventing fragmentation. In the middle there, we have Velocity Server for physical Windows machines that have a higher I/O load, maybe a physical SQL server or a file and print server. Perhaps it's leveraging virtual storage like a SAN or a NAS. On the right-hand side, this is what we're interested in today for the VMware virtualized environment. We have Velocity VM, which sits inside those guest Windows operating systems, optimizing the traffic and helping to alleviate that chaotic I/O storm that is bottlenecking down towards your storage. So, last slide, I promise. This is a brief summary. So with Velocity, we can increase application and system performance by, on average, 50% with a non-intrusive, software-only approach. We don't need additional hardware. We're not saying that in order to do our caching, you have to take a machine offline, crack open the case, install a piece of hardware, and suffer all of that downtime. All you need to do is reboot the operating system. And because we don't have additional hardware as a requirement, that means we don't require extra electricity to power any extra hardware. We don't need any extra space in one of your racks. We don't require extra floor space in your data center. Now, in a large data center, that's important. Also, if you're using somebody else's data center, you'll know the more things you have there, the more expensive it is. So it is a non-disruptive approach to this increased performance, and it allows you really to get the most compute out of the money that you've spent on your virtualization infrastructure today, without the need to keep buying this additional storage hardware to maintain performance and try and alleviate those bottlenecks. Now, you probably realize I'm more of a techie than a sales chap. I intentionally don't get into the sales side of things very often, but I'm sort of predicting one of the questions which somebody's going to ask, which is how much does it cost? We have tried to price it so that it is roughly 10% of the cost of the hardware that you would need for the same performance gain. So the software solution should be cheaper than the equivalent hardware solution, and that's not taking into account the other ongoing expenses like electricity, rack space, or floor space, and so on. So that's the end of the presentation. I'm happy to take any questions that any of you want to throw.